गुरुर्ब्रह्मा गुरुर्विष्णु गुरुदेवो महेश्वरः गुरु साक्षात् परब्रह्मा तस्मै श्री गुरवे नमः.
Today, we will perform an experiment called electrolysis of water. This setup includes a battery, electrodes, and water with a little electrolyte. Now, I connect the battery to pass electric current through water. Observe closely, bubbles start forming at both electrodes. Hydrogen gas collects at the cathode and oxygen at the anode. This proves that water is made of hydrogen and oxygen. Come, let's know how to draw a neat diagram about electrolysis of water. My friend Ai Gurudeva will explain about this. Over to Mr. Gurudeva.
Hey everyone, welcome. Today, we're going to break down a classic chemistry diagram that, let's be honest, trips up a ton of students. The electrolysis of water. Stick with me, and I promise you'll be able to draw it in your sleep. You know the feeling, right? You flip open your exam paper, and there it is. Draw a diagram of the apparatus used in electrolysis of water. Your mind just goes blank. Well, we are about to make that a thing of the past. Right, take a good look. This is our end game right here. It might look a little complicated now, but by the end of this short explainer, you're gonna know this thing inside and out. You'll be able to draw it, label every single part, and even explain how it all works. For real. Okay, let's dive in. Think of this like we're building something out of Legos. We're just gonna follow a simple step-by-step blueprint. If you've got a piece of paper handy, maybe try drawing along with me. So let's build the mainframe. Step 1, just draw a basic container. A plastic mug is perfect. Next, at the bottom of the mug, pop in 2 little rubber stoppers. Easy. Now draw 2 straight lines, which are our graphite rods, going right up through those stoppers. And finally, plop an upside-down test tube over each of those rods. And just like that, the main structure is done. See? Not so bad. All right, time for the finishing touches. Let's add the water, draw a line for the water level, but make sure you leave a little bit of empty space at the very top of those test tubes. That's super important for later. Then we need power. So draw some wires connecting the rods to a 6-volt battery and, of course, a switch. And lastly, let's mark where our gases are gonna go. Oxygen in one tube, hydrogen in the other. And boom, you've got a complete exam-ready diagram. Okay, a perfect drawing is awesome, but in an exam, the labels are where you score the easy points. So let's make sure we know exactly what to call every single part. Think of this as your cheat sheet. You've got to label the plastic mug, the water, the graphite rods, and the rubber stoppers. Then you have the test tubes, the 6V battery, and the switch. And of course, the whole point of the experiment, the oxygen and hydrogen gases. Oh, and don't forget this one. The anode is the positive terminal and the cathode is the negative. Get all these down and you are golden. So we drew it, we labeled it, but what actually happens when we flick that switch? Let's bring this drawing to life and see the chemistry happen right before our eyes. Everything kicks off the second we close that switch. Imagine that little click. Suddenly, electricity starts flowing from that battery, down the wires, and into those graphite rods sitting in the water. The process has begun. And here's the first thing you'd actually see. As soon as that current hits the water, you'll get this fizzing. These tiny little bubbles start appearing all over the surface of both rods. Now, this isn't the water boiling or anything. This is the water molecules literally being ripped apart by electricity. How cool is that? So where do all those bubbles go? Well, they float straight up and get trapped inside those upside-down test tubes we drew. It's a really clever, really simple way to actually catch the gases that are being produced so we can see what we've made. As more and more of those gas bubbles collect at the top, they start to build up pressure, and that pressure literally pushes the water level inside the test tubes down. This is the key visual proof that the reaction is working, and it's how we can measure how much gas we've collected. Now, pay close attention, because this is probably the most important part for your exam. The 2 sides do different things. The positive side, the anode, collects oxygen gas. The negative side, the cathode, collects hydrogen gas. And here's the kicker. Since every water molecule, H2O, has 2 hydrogens for every 1 oxygen, you will always make twice as much hydrogen gas. So you'll see that cathode tube fill up twice as fast. That 2-to-1 ratio is a huge deal. Remember it. I know, thinking about molecules splitting apart can be a little abstract. So to really make this idea stick in your head, I've got a fun little analogy for you. Just picture it, a huge, fancy ballroom, and it's filled with dancing couples. Each one of these couples is a water molecule made up of 1 oxygen and 2 hydrogens all grooving together. So in our dance party analogy, that 6-volt battery is like the DJ suddenly cranking up a super energetic song. It's so intense that it forces all the couples to break apart. Once they're separated, the individual dancers, all the hydrogens and all the oxygens, run to opposite sides of the room to hang out with their own kind. And those opposite sides of the room? Well, those are our electrodes, the anode and the cathode. And really, that's all electrolysis is. When you boil it all down, it's just a fancy way of using electricity to split molecules. A simple concept, but it has some really powerful implications. It makes you wonder, right? If we can do this with something as common as water, what other invisible processes are just waiting for a little spark to be unlocked?